this video we'll be looking at section 3.5, Arithmetic Sequences. So our essential question for today will be, how do I write and graph arithmetic sequences? So before we can begin discussing arithmetic sequences, let's talk about what a sequence is. And a sequence is simply an ordered list of numbers. And an arithmetic sequence is a sequence in which the difference between consecutive terms is the same. A sequence in which the difference between consecutive terms is the same. So what that means is if I look at two terms, let's look at example 1 for instance, is there a difference when I go from one term to the next? So as I move from -7 to -14, the difference is I'm subtracting 7. And then as I move from -14 to -21, the difference would be I am subtracting 7. And then as I'm moving from -21 to -28, the difference is I'm subtracting 7. So this is an arithmetic sequence because I'm either, the common difference is a -7. I'm subtracting 7 every time. A common difference can also be a positive number. Say I'm adding the same number every time. So we're either adding or subtracting every from one term to the next. So if I want to write the next three terms, I'm just subtracting 7 every time. So -28 would then be -35, comma, -42, comma, and then -49. And there's my next three terms. Now something I want to point out is the notation we'll be using. And what you'll see is this A with a sub number. A sub number is a lower number, so like A sub 1. And what this means is the first term. The number 1 telling us that it's the first. Whereas say like A sub 4 would equal the fourth term. So in our example, say I wanted to find out what A sub, if I was talking about A sub 2, I would say A sub 2 is equal to our second term, which would be -14 right here. So we say A sub 2, the second term, is equal to -14. Another example would be, what is my fifth term? Well, A sub 5, the fifth term, is equal to -42. -35. Apologize. So we'll be using this kind of notation where the 1, the 4, this 2, and the 5, these sub numbers don't do any math necessarily. They're not an exponent, or they don't do a multiplication or addition or subtraction. They're simply a labeling tool. So when I see that sub number, that sub meaning lower, or kind of on the opposite side of where an exponent is, A sub 1, that's telling me the first term. It's just a labeling, a way to label stuff. Okay, so let's find the next three terms in the sequence. Well, it looks as I go from term to term, I am adding 12. Negative 12 plus 12 is 0. I'm adding 12 to get there, and then I'm adding 12 to get here. So I'm adding 12 each time for this sequence. So my next three terms would be 36, 48, and 60. Now, would you please tell me what the a sub 1 equals, a sub 3 equals, and a sub 7 equals? Well, a sub 1 is our first term, negative 12. A sub 3 is our third term, negative 12, 0, 12. That's our third term on our list. And a sub 7 is our seventh term, 1, 2, 3, 4, 5, 6, 7. The seventh term being 60. So that's how we're going to use this sub number to label the terms in our list. Okay, so the way we graph these is we're going to treat the 4, 8, 12, and 16. These are our y values. Right here. And our x values are kind of their order in the list. So say I was building a T-chart for this. My y values would be 4, 8, 12, 16. My x values would just be their order. So my first term is 1, my second term is 2, my third term is 12, and my fourth term is 16. So then we can plot these. Let's say I'm count by 2's along the side. And then we'll count by 1's along the bottom. So when I'm at 1, I'm at 4, 2, 8, 3, 12, and then 4, 16. And if we connect these dots, what kind of graph is this? This is a 1. Now, we do have an ability to grab any term from a list. So, like say we're looking at number 1 and number 2. Finding the seventh term wouldn't be too difficult because I'm just going to list out 3 more terms. I'm given the first 4, then I'll list 3 more out, and I'll find that seventh term. But what if I want to find the 327th term? Am I going to list 327 terms? Well, we could, but there's also a way of doing this where I can use an equation that helps me. And our equation to help us is a sub n is equal to a sub 1 plus n minus 1 times d. Now what this means is a sub n is the nth term a sub 1 is the first term and d is the common difference. So we have a sub n as the nth term. So say I'm looking for the 47th term, I'd have a sub 47. A sub 1 is the first term, so we're given a list or we're told what the first term is. And then d is the common difference. That's when I have a list, I decide that it's that plus 12, a positive 12, or if it's that negative 7, that common difference getting from one term to the next. Okay, so let's look at this one. Write an equation for the nth term of an arithmetic sequence, 14, 11, 8, 5, and then find a sub 50. So what we'll need to identify is what a1 equals and what our d equals. And once we identify these things, we can plug them in to our equation. So our first term is going to be the first term listed. That's our 14. And then our common difference would be, well, I'm going down by 3 every time, so my common difference is negative 3. Now we can build this equation. So I'll have a sub n is equal to my first term, 14, plus, and on the inside, we don't know what n is yet. We're not plugging in. We're going to write this in terms of n, so n minus 1. And then I'm multiplying that by negative 3. That's that final piece there. Now, the thing is when I replace this n right here, the little n, when I replace it with a number, whatever number this n becomes, this n changes to that number. And this n I'll actually do math with. This n is just a labeling technique telling me the 50th term, and this n I actually use in this equation. So this n and this n become the same number. So if I'm looking for the 50th term, I would say a sub 50, and here this n is turning into my 50, is equal to 14 plus, then I'll have my parentheses, and on the inside, since this n has become 50, this n must now become 50. So I have 50 minus 1, and then we'll take this and multiply it by negative 3. Now we simplify this, and this is just order of operations. So I'll say that my 50th term, a sub 50, is equal to 14 plus 50 minus 1 is 49 times negative 3. We multiply 49 times negative 3, and we'll get negative 147. Then we combine these two, and we'll find that a sub 50 is equal to negative 133. So that's how we can find the 50th term. We identify our first term, 14, identify our common difference. This sequence is decreasing by 3 each time, so it's a negative 3. We plug into our equation. A sub n is equal to 14 plus our n minus 1 times negative 3, my first term and my common difference. Then since I'm finding the 50th term, I change my n's into the number 50, and then I simplify from there. So just for a quick note, one thing we'll need to have like a definition of is whenever we're looking for an explicit form or the explicit rule or formula, this part right here, before we plug the n in, is our explicit formula. And what that means, it's like the general one. So this is the formula we would use to find any term. So anytime you're looking for an explicit formula, you'll have the letter n's in your formula. You won't turn those into numbers. Okay, well that's it for this lesson. So thank you for watching this video, and I hope you have a great rest of your day.